They look like amoebas, but they're much bigger. And then notice they're all going different velocities.
This view showing...
Had that been debris in Galileo and Newtonian physics can't move through a gravitational field at different velocities. And notice they're all going different velocities.
The satellite.
That's very curious. And they never bump into each
Again,
other. If it was
just
debris,
moving in
you
the
think
sunrise.
two pieces would hit each other. It never happens.
81 nautical miles now from Columbia.
Yeah, I think it's possible a lot of UFOs could be life forms. You're about to see someone coming up who believes in that. The pioneer of invisible photography, Trevor Constable, is coming up after this. It overloaded. There was too much energy in the ionosphere, more than they calculated, so it shorted out, it snapped. And yeah, there's actually classified reports on NASA's site about certain aspects of this incident.
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angle. So there's a lot of stray light, and it's getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Notice the pulsing.
Copy that.
Very fast pulsing. Some of them pulse at different rates.
Again, that description by the crew, this is the tether in the satellite. The satellite with approximately 12 miles of tether still attached to it.
Look at that one, just pulsing away.
Columbia and the satellite now just passing over the west coast of northern Africa.
Actually slowed the waves down and took
spacecraft
pictures of
now
them and ran them through a wave clock and pretty much translated what the waves are actually doing.
Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
Notice how they look like they're spinning, but when you zoom in on them, it's the pulses that give the illusion of spinning.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
This is, I confirmed with top scientists at NASA that this camera sees near UV photons. They also have cameras that see infrared, and this camera is seeing visible and near UV. And near UV is as wide in bandwidth as from red to violet. It's a huge, huge spectrum. Ultraviolet is divided into ultraviolet near, ultraviolet far, and ultraviolet extreme. And all three of those combined are about 6 or 7 times as wide as the bandwidth that the human eye sees. So it's an enormous spectrum to search for phenomena. How what? It's 12 miles long. We're about to get into that. Because they go behind the tether,
Satellite now.
we can use the length of the tether to measure their diameter.
100 nautical miles.
Completely unzoomed, and
very busy day, like Jaime Maussan's videos, 150 UFOs.
But I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.
Well, this is, of all the stuff Martin Stubbs collected, this is like the mother lode. This is the day when a lot of them showed up. In the summer of 1999, I met with Martin Stubbs, the program manager of the cable TV station, who had recorded over 400 hours of NASA's live broadcast. He gave me some videotape on a new incident that happened in February of 1996 on Space Shuttle mission STS-75. In the summer of 1999, I met with Martin Stubbs, the program manager of the cable TV station, who had recorded over 400 hours of NASA's live broadcast. He gave me some videotape on a new incident that happened in February of 1996 on Space Shuttle mission STS-75, what was called the tether incident. So what you just saw on the videotape showed a 12-mile-long satellite, a satellite attached to a 12-mile-long tether, which is like a conductor cable. It's a very, very thin, 1/10 of a centimeter in thickness cable that was used to conduct electricity in the Earth's ionosphere. As we saw earlier, space is supercharged with high-energy particles, and NASA was trying to take advantage of these particles to see if they could build up a charge on the tether and actually see a gain or produce some electricity. They charged the tether with some electricity, but then an overload of highly charged particles flooded the tether and produced so much electricity it snapped. On February 25th at about 7:30 p.m., the tether broke away from the shuttle Columbia and drifted about 77 miles away. So the scene that you just saw actually starts at about 77 miles away. The camera pans down. We see a long line, which is 12 miles long of tether, a small satellite attached to the end, and then a swarm of little objects, little balls of light, just moving in from all different directions in different velocities and different speeds. Then the cameras actually zoom in, and we actually get to take a close look at what we're seeing here. It's astounding. We see up here in the right-hand corner, we see a very large disk clearly going behind the tether. And we can actually see little black dots racing around to suggest some sort of a magnetic field effect. And coming through the middle, we see another very large disk moving clearly behind the tether. The light from the tether shines in front of the background object, which is the UFO. If we use this piece of wood as an example, we can see what a disk looks like when it's passing behind a foreground object. It's really very quite simple. So if the disk was passing in front of the tether, it would look something like this, and it doesn't look like that. When we look in the middle and we see this large disk passing through the middle, we can see again it's passing behind the tether. If this was the tether and this was the UFO, we could clearly see it's going behind. And if it was going in front, it would look something like this. It doesn't look like that. So because we know the shuttle is at least 77 miles away and drifting further away from the object, from the tether, and we know the objects are going behind the tether, we can therefore use the 12-mile length of the tether as a relative measuring rod for actually making measurements of the minimum diameters of some of these disks. And according to my calculations, against the 12-mile length of the tether, this disk passing through the top section here measures a minimum of 2 to 3 miles in diameter. That's assuming it's right up next to the back of the tether. If it's actually farther behind the tether than I think, then the disk could be much, much larger. The further it gets behind it relative to the distance of the tether, the larger it actually is in reality in compared to measuring
a little bigger
against
than the
tether.
Phoenix UFO.
Again, here, this disk going through the middle here, I estimate it to be between 2 and 3 miles in diameter.
And the same translucent mass.
If a UFO were flying over the city of Los Angeles in the downtown core or New York, and it was 2 to 3 miles wide in diameter, it would black out the entire sky. It would be an Independence Day-sized craft that would literally cause massive panic and massive alarm. But again, when you consider that the cameras on the space shuttle here are seeing into the near ultraviolet spectrum of light, as we learned earlier, it's a spectrum of light that's too high in energy for us to see with our eyes. But because the camera can see into it, it can basically be capable of capturing an image that is so high in energy that although we can't see it with our eyes, it actually still is there. We just can't actually see it. Earlier I suggested how if a UFO were capable of doing light speed travel, a solid object initially, and it could change its frequency into high frequency energy, the UFO would still, or spaceship would still have actual structure to it. It would actually still have mass, but in its high frequency state it would turn into pure energy. Therefore, as it would appear on a camera, it would be very translucent. It would look like energy even though it has structure. And that's exactly what these objects look like. They look like almost transparent, translucent disks, which actually, as they pass behind some background stars, you can actually see starlight shining through them to suggest that they're in a pure wave or energy form. So, and again, this one, we can see the actual magnetic field rotating very, very quickly around the craft, suggesting that what we're looking at is pure energy, mass vibrating at a very high frequency. Across the top of the screen, we can see a very powerful pulsing coming off of one of the UFOs as it moves across the screen. Later, I would look very closely at the wave patterns on the UFO and study the wave patterns and find some incredible, incredible conclusions, incredible quantum physics and quantum energy equations. But we'll look at that much later. For now, we're left with the most astounding event ever captured on film.